Hello YouTube and welcome to GrunfWorks. This is the second episode of the Kerbal Engineering 2000 subscriber special. In previous episode we have assembled this IP Duna Colonizer Mark I, and today in this episode we will be dissecting it according to the modules, packing it into launchable stages and test launching it to the orbit, roughly orbit of 130 kilometers. So, let us go onwards. This is our vessel that you can see here. And first of all, I want to remove the SSTOs because those will be launching separately. Okay. And then I want to detach the drive section. And I'll detach it here at the Clampotron docking port. Okay, so this is the part 1 of what we will be launching in the first stage. It's a little bit huge, but we already have some experience with launching huge stuff. If you remember from my Interplanetary Voyage Series, which this is very much tied to, I launched the Duna Aeroponics module. So here are the plans for the station core, part 1 of what we will be launching. And to the left you can see the launcher. In this episode I will be showing you how to build and actually how to test launch it. So first we took the ship that we have just loaded from the spaceplane hangar. I'm trying to position it as centrally in the VAB as I possibly can. And then we have the step 2, which will be roughly trying to find a way how to launch this bad boy to space. Or at least to the 130 kilometer orbit. So my main dilemma was, should I have something underneath as I did for the Duna Aeroponics module? And I probably will, but it will be actually a short stack as opposed to some longer stage. So I want to be putting this short stack separator followed by some sort of adapter that will be hopefully converting this to a bigger format. And I'm thinking here roughly 3.75 or even bigger. Maybe 3.75 would work correctly. So, only adapter and the engine. Not too much fuel in there. But I do want to be attaching something more. And I'm actually going to use the docking ports that we have on this craft to do so. So I'm actually putting the docking port, then on docking port I'm putting the radial attachment point, and then on that radial attachment point I will be actually attaching the 3.75 meter, or is it 2 meter? I think it's actually 2 meter fuel tank. And the whole purpose of this is to actually have 2 huge boosters on each side that would basically help me get this one to space. So given its length, it will be not an SSTO but almost like dual stage to orbit, roughly. So I have to make sure that these huge boosters do pack a nice punch. So I'm trying to figure out what I should use underneath. So let me just give it a quick look. I have put enough fuel tanks. Now I need engine powerful enough to actually get this guy off the ground. So, and I then remembered this little fella. And I'm actually thinking it looks kinda nice. So I'm just gonna slide it a little bit down so that those two are aligned. And I think this will actually work pretty well. They look actually pretty cool. So I'm just gonna now put double symmetry. And I'm gonna attach one on each side. Granted, I'm not the happiest that those are attached by docking ports, because the forces there are not the best, but then again, I think we'll just have to live with it. Okay, so this is basically what this craft looks like. So I have to fix the staging, obviously, but first I want to strut it a little bit. And also I want to make sure that I connect the fuel lines, because each of these boosters will feed into this main stage booster, and those two, after they are expanded, I'll just decouple them and hopefully then we'll get rid of them. So that's kind of the plan. I'm hoping it will work. Okay. So, with that thing in mind, let us just strut the crap out of it. Awesome. Struts, struts, struts. You know, more boosters first and then more struts. And I'm now looking just to fix the staging, and let's see how our thrust to weight and our delta V looks like. 5,600 delta V, I think that should be pretty fine, and 2.111 thrust to weight on takeoff. How much it will be once the boosters are removed, I don't know, but I'm actually hoping that, given that the delta V of the boosting stage is 3.8 thousand meters per second, I'm hoping that I will be a long time in the orbit by then, and then I don't need to care how much is the other boosting stage. Okay, so this is pretty much what I'm looking at. And 2.5 meter stack decoupler, this is correct. And yeah, and these separatrons are firing. Okay, I just want to have stack decoupler separate from activating my nukes. So, let's simulate the vessel, shall we? Then I remembered, before I press the simulate the vessel, I do want to add this launch stabilizers. After all, I mean, they're kind of important. Okay, I think we're ready now. So, this is really a monstrosity. So, but not the biggest one that I've launched yet. I think I've launched even bigger ones before, but then again, once this ship gets assembled, it will be the biggest thing I have ever launched. And with that in mind, Jeb, Bill and Bob have volunteered for the simulation. Okay, boosting happily away. It looks pretty stable. I'm deliberately going for a little bit steeper ascent profile, angling ever so slightly, because it's a long stage, you know, you don't want to overdo it. Our periapsis is rising steadily. Our thrust weight is around 2, which I consider very nice. And our fuel economy is, we have roughly 2.4 thousand meters per second, so we have plenty. Okay, beautiful. Let us just do the gravity turn a little later than I would like to, but once again, we have to think about that this stage is humongous, and once the boosters separate, well, we will not have that much thrust to weight. So yeah, thrust to weight, sorry. So I am ejecting a little bit higher, 110, and I hope to circularize roughly at around 130. I'm starting 110 by 110, but then again we will see. 1,700, just shy of 1,600 that I have, so I will have to do some boosting with the final stage, but I guess that's fine, so yeah, perfectly okay. Just aligning it, and we are already in orbit, so, or not in the orbit, we are above the atmosphere, sorry guys. So now let's see, passing 100, and our maneuver node will be in 55 seconds, and our estimated burn time is 45, but it will be actually a little bit longer since we will have to ditch the boosters in the process, so yeah. Hitting the gas, and now I'm just monitoring as my liquid fuel and oxidizer drain from my actual boosters. Those are done, and now I'm just decoupling the node here and decoupling the node here, very gently tapping the gas, and as I leave these two guys away, and 500 more to circularize, and we have those 500 roughly. So yeah, just monitoring my fuel and also monitoring my periapsis, and as you can see, we are already 101 by 130 with 100 meters per second to actually circularize, so this is actually just right. I mean, we do have our nukes with 3000, but then again, I really don't want to use them. Not at least for the ascent stage, so let's just see how much it will take us to circularize at 130, and that's 23 meters of the 100 that we have. Beautiful. I'd say that this simulation is awesome. Few more things to try out just to see that they are working correctly. We do have 4 hours more for simulation. I doubt that we will need that much, but then again, after all, we do want to make sure that everything is running as it should. Pointing towards the maneuver node. Okay, and getting ready to circularize, or just slightly, not really circularize, it already is circular, but just slightly adjust the orbit. Perfect. Okay, detaching the boosting stage, and I think this warrants a screenshot, don't you? I doubt that I will be using that one for the episode because I will be using other ones, but right now we have our nukes. I wanted to test them. This is a simulation anyway, so everything what we do here will be reverted. So I just wanted to test this and test the staging. Our booster separation went swimmingly. Perfect. I think, guys, this is a very successful separation. So testing one final thing, and that's decoupling the space tug. Okay, as you can see, our tug works without any problems. And let us go back to the station part. Now, it is remote tech, so it has the probe core, which is important, and it is actually balanced, so it can do some docking. So I wanted to deploy these two parts, and as you can see, our remote tech station is fully functional, and we can actually use it without bigger problems. Beautiful. Okay, that being said, that is the part 1. Then we have the part 2, which is the drive section. And this one is pretty hefty, so for this one we will be using I guess, 5-meter parts for the first time ever, basically. So let me just do one more thing. I do want to select root here, and I had to select the root part here, and then I'll rename it to part 2. So when I decouple, I did it so that when I decouple this forward section, I'm left with the rear section as the main ship. So that was kind of the idea anyway. Oops. Yeah, like this. So this is the drive section, including the rovers, of course. This is the second section that we will be simulating and trying to get to space. Okay, just balancing it out a little bit. In terms of RCS, you have to remember we don't need to RCS stabilize the whole ship. We don't really care about that, but what we do care about is that we stabilize the components going into the full ship, because those will need to be docked and assembled in orbit. So for us it's really important that the forces being executed are minimal. So I'm just now balancing this guy out so that we can actually perform docking with that. And you might want to ask yourself, okay, but how will I control it? Well, simple enough. I will add here a probe core, and I will add we already do have probe cores that are from these, from the rovers, I guess. So we can use those as well, but I think I'll add like a large remote unit just to be on the safe side. Okay, so we have strutted the rovers, and I think I'm happy with what it looks at the moment. So I think I will actually go to the VAB now, and I will continue assembling it. Now, as you can see, I have added to the bottom large probe core, the 2.5 meter one. And now it is time for us to put the 5 meter fairing base, and it's not 5 meter but 5 meter expanded fairing base. So I think this will be by far the first 5 meter that I have ever launched. So actually I don't need this guy, I need just something more. Let's see. Come on, attach please. Perfect. Oh dear, oh dear. I'm actually worried that these rovers that are attached to will be sticking out. Rovers that are attached on the sloped part. So I actually might need to move them. Like this. And like this. Oh yes. Well, this is not gonna cut it. I mean, theoretically I could live with it, but then again, I really want to pay attention to every detail, and I hate cheating. So, let's do it like this. Okay, so we do have some leeway in terms of we could move everything a little bit up and then put the docking ports over there. So this is what we're gonna do, guys. I'm gonna raise this a little bit. I'm gonna put another RCS fuel tank here, which will hopefully make this sticking a little bit more. I will rebalance the whole thing with the amount of RCS thrusters, hopefully even less, because now we have a longer, slightly more elongated guy. Okay, and now I want to be putting these two rovers actually down on this guy. So let me just first remove these struts, and okay, these two rovers are now going here. I don't know how this much will affect actually the balancing of the whole craft, but then again I'll have to see. And I have to put not like 8 radials, but just 2 radials. I think those should be enough. We don't want 8 rovers. Okay, a little bit higher up. Something along these lines. And I'm thinking that those will actually work swimmingly. So let me just check. In terms of balancing, we do have slight rotational moment. Let me just make sure that I balance that one out. Yeah, like this. A little bit too many RCS for my taste, but I'll have to live with it. So let us just now strut the rovers. Perfect. Strutting from here as well. Great. Then putting the 5-meter base, and as you can see, the tires and everything is now fitting in. So let's see if everything will fit in correctly. Beautiful. Okay, I mean, I'm really proud of this design. At least that I managed to fit everything in a 5-meter extended part. So let's see how we're gonna get this guy into orbit. I just hope that I have big boosters. So, oh dear, this is the 3.5. Okay, this is the 5-meter one. So I'm thinking, oh no, this is the wrong form factor. So I seem to be missing the biggest boosters that they have. I don't think I have unlocked them yet in my tech tree. Oh dear, oh dear. Okay. Because, I mean, the save that I'm playing this is the Interplanetary Voyage of Exploration. It's just a different episode because this is focused on the building. Okay, and we have 0.78 thrust to weight. Oh dear, this is... And delta V is... Okay, it's not correct because the staging, I think it's a little bit messed up. So I will for sure correct this. Let me just see, fuel tanks. I'll put first you, then you. So a shorter tank, still not good enough. Let's move this around. Okay, that's more likely. 1.9 thousand? No, I don't think so. Okay, let's put the big one as we did before. So 3,300 meters per second. Okay, that's better. Still not good, but better. Do we have like this one and then the big one? I was thinking something like that, and then I realized that my technology level does not allow for the 5-meter stack separator. That I have not yet unlocked. Okay. That pretty much means we'll have to make do with what we have, and that will be the big tank. I'm trying hard to see if I do have something that's 5-meter. Either interstage or decoupler, which I don't. Okay, now I'm getting slightly concerned if we will be able to get this guy into orbit with the current tech level that we have. Oh dear, because I mean this would work, but it's too big. So let us go back to our initial thought. As big rocket as we can, slap it here, 0. It's 1.39. Okay, so guys, this is doable. I just need some side boosters. Okay, let's just see. Okay, radial decouplers, and then I want this big boosters, sure. Those look pretty decent, and I want to put 3.75 meter engines on top. Yes, this would work pretty nice. 4.3 delta V, that's much nicer. But then again, let us just put some struts. And we need some fuel lines. Oh yes, and the 5-meter SAS. and we need some, like I said, we need 2 fuel lines to connect these boosters with the main stage. Let's just see where I'm gonna do that. Somewhere from here inwards. Perfect. Okay, and now we look much better. 4.6 thousand delta V. I'm hoping that that should be enough. Okay. I'm thinking of adding some RCS. Not that we don't have enough in our original craft, but still, I mean, this rocket will require quite a lot of boosters here, or RCS thrusters here, just to make sure that it's controllable. After all, it is a huge section that is inside, so we don't want it to be maneuvering like an aircraft carrier now, do we? So, okay, and then I'm thinking, okay, from the science, I do want this guy to have one antenna, at least for the orbital ascent, and I do want to make sure that I'm putting in also these struts. Slightly higher. Okay, so I guess this looks correct. And let us simulate the vessel. Nothing happens. Okay, let's just briefly fix the staging and let's simulate the vessel again. Okay, I guess something is a little bit wrong. Maybe my KSP... Yeah, by the way, guys, my KSP just didn't want to accept the simulation for some strange reason that is completely unknown to me. Okay, let's see. SAS on, throttle to max, and boost. 1.6 thrust to weight at takeoff. Pretty good. Our rocket is looking very sleek. Something that happened, I assure you, completely by accident. I didn't have that in mind when I was designing it, but I'm pretty happy the way it turned out. So, okay. Just now making sure that I maintain my ascent profile, and I'm a little bit concerned it is a little bit wobbly. I don't want my thrust weight to be too low because my fuel economy will suffer. So let's see, and boosting and separating the boosters, and our thrust weight is at 1.5, so we should just continue. This was the reason why I didn't want to be very slow on ascent, because I wanted to accelerate to a decent speed with my boosters still attached. Okay, now we are already at 30,000 meters and we are angling slightly prograde. Similar as the previous launch, slightly worse or not suboptimal ascent profile, but then again I want to really make sure that this thing gets to space in the first place. We have pretty decent thrust to weight and pretty decent fuel economy so far, so I'm cautiously optimistic. I just want to make sure that I push it as far as it can go. 130, perfect. Detaching, and I want to make sure that I extend at least one communotron, because I remembered after all this is a remote tech launch craft, so yeah, I didn't put any communotrons on the rocket itself, so that's something, I mean, I don't need it because we have rovers. Okay, perfect. So this is the second stage, or second part that will be launched, and now I'm just making sure that I line up correctly. And here you can see the thrust to weight, or not the thrust to weight, the RCS thrusters coming very handy. Okay. And coming ever so closer on our estimated burn. 1200 and we have 1900, so we have absolutely enough fuel to be circularizing, I guess, correctly. I'm just waiting until we are roughly 40 seconds, and I'm slowly accelerating because, guys, with these things from the KW rocketry, there is no instant, throttle to max, so you have to slowly accelerate it up and then slowly decelerate it. So that's something that I forgot to put in, like instant thrust. But then again, I don't mind playing as is. So slowly circularizing, and 130 by 190 by 117. I mean, it's not the optimal height, but then again, it's enough. We can just maybe see that we extend it to 130 or by... I just want to check that we have enough delta V to circularize despite a slightly suboptimal launch profile. And the moment we hit 130, I will proceed to the next part. I mean, while we're here in the orbit, we do want to test everything, so it is really important for us to make sure that all components are working properly. You don't get many simulations with this, guys, and you really want to make sure that everything is correct. Okay, let us... We have some lovely signal bounces off various satellites. Closing in on the burn. Fortunately, it's a very minuscule burn, so I feel comfortable coming very, very close to the wire. Sun just came out, so might as well extend the Megalodor panels. Beautiful. Okay. Circularizing. Perfect. 194 by 132. I do not think that I will be pushing for 130 by 130. Let us just decouple now from our boosting stage, and let us make sure that the actual drive section is working correctly. I just had to fix staging here a little bit. Ooh. Okay. And this seems to be working fine. Okay, I was just curious, and here I noticed that I have liquid fuel and oxidizer fuels that I'm actually not using because I'm using liquid hydrogen here. But then again, I remembered I actually do use them at a later stage when we dock the ship together. So I was thinking that I should actually withdraw the fuel from here, but then again, it's fine. Oh, a battery short-circuited. Thanks for adding the value to our simulation, dang it. Now I have decoupled the rovers. Okay, time to visit our third part, which would be the space planes. And here you can see the launching stage, and we have two SSTOs that we would be launching. One is Discovery and another is Voyager. I am gonna explain why I named them so and what are the difference. So let us first construct the boosting stage, shall we? We now know that we actually can launch the 5-meter rockets into space. So here we are designing a small command because this time we will be taking into orbit actual Kerbals. I mean, we did it also in the first launch, but here I'm hoping to send most of the crew here anyway. So let us put some parachutes, and I am putting the launch escape system as well. Okay. This certainly looks pretty good. So now I'm actually mapping my controls to the abort stage just to make sure that I can safely eject my Kerbals if push comes to shove. So I'm arming the parachutes, launching the escape stage, and decoupling the decoupler. So that should be what happens. So let's just name the craft. We call it Utility SSTO Launcher IP Interplanetary Duna Mark 1. Okay. That being said, we are gonna slap 2.5 meter to actually 5 meter, and let us put some big tanks here. I'm thinking something like that, and then followed by something like that. Perfect. So engine here, 1.20 thrust to weight. I think that should be fine. So, and you'll notice also this is almost also single stage to orbit. Yeah, well, we don't want to be decoupling too many stuff. So we are now attaching our space planes here. And I have two. One is actually... I first remembered that I need to attach the docking port because my space planes don't have the docking port, sadly. So this is the Explorer, I believe. And actually during this stage I was actually planning to send two which are exactly alike, and their mission would be basically to go to Duna and ferry people on and off, but not just ferry people, but do some experiments, some cargo, etc, etc. But then again, in the later stage I was thinking, hold on, I actually want to be launching Kerbals, and how will I ferry my crew between Duna, Orbital, and Kerbin? So I have actually changed my mind a little bit later on, you will see that, where I'm putting two not exactly same craft. Okay, so I have extended the fuel lines because I will be using the boosters of the SSTOs as well. Not the boosters, but the... what do you call them? The actual rockets for the SSTO, rocket motors. Just making sure that we put enough RCS thrusters. Okay. And some on the top, because this will be quite a long vessel that's being launched. 5 meter SAS. Okay, let's save it, and we have 1.15 thrust to weight at, which is not enough. So I'll actually need to think about something else. By the way, guys, this is the first time ever that I'm designing a launcher like this. I have designed previously launchers like the ones that we had, Launcher 2, namely, but the 1 and the 3 are the first time ever for me, so yeah. Okay. This will be cutting it a little bit close, but I want to put my launch clamps as well. And this is the point where I actually decided to put different SSTOs. So I reworked things a little bit later on. So let's see now. I want first the Scout, and this is Discovery. So this one's mission is just go land on Duna and do some experiments, scout the position for our future base. Then we have the second SSTO, which is actually the passenger one, and that one is Voyager. So you will see they're not equal length, and that is because our Voyager has replaced its top docking port with actually the Mark II crew cabin. So I'm scaling down the number of parts that we're gonna ship it off with, because I do want my launcher to be roughly even in weight, because otherwise this whole rocket would get a little bit flippy. Also, you will notice that I'm connecting the SSTOs at the bottom of the rocket, and there's a really good reason. I have been experimenting with the launcher where I had SSTOs on top of the rocket, and they were super flippy. If you guys are very interested to see what happened to them, I might be posting an episode later. I won't make any promises, but I might be posting an episode. Let me know in the comments if you'd like to see it. The fault that I made there was SSTOs have wings, and wings move your center of lift. So you want always the center of lift to be behind your center of mass. So the center of mass on this vessel is actually a little bit higher up. So the wings are at the back, so we don't need to care. So the rocket will be dynamically stable. The problem with the previous launcher, since the SSTOs were high up, this, what you call it, center of lift was way ahead of center of mass. So that was the main problem. Okay, and I just wanted to make sure. And I just wanted to see how much thrust away do we get. So I once again have to fix my staging. Sorry guys. So that was kind of the deal, or my reasoning behind it. I wanted to see how much difference in weight is between these two SSTOs, or maybe not even SSTOs, they're shuttles, space planes, whatever. So, okay, spare parts, like I said, reduce it. And also in one of these space planes I'm carrying a lot of struts for the Kerbal attachment system. Since you saw in my craft, we will need to dynamically, or not dynamically, but we will need to attach the space planes even after we have docked them to the space station. Or not the space station, the interplanetary vessel, sorry. Okay. I have also used a couple of tricks when I was modifying them so that they are radially attachable. And these docking ports that you can see on the bottom of the craft are actually the reason why. So yeah, strutting, making sure everything is strutted correctly. And I will be putting actually the RCS fuel tank only on this side, because to balance the craft out. I found that roughly, I believe, 2 RCS fuel tanks should be able to balance the craft out from both sides. Okay, save, and let us just put 2 more side boosters, because I have been thinking and I saw 1.13 is definitely not enough thrust to weight, so might as well be putting 2 like these 3.75 big boosters. And besides, our rocket will look pretty cool with them anyway. So something like that. Now let's look for the correct engines. We're looking for the 3.75 meter ones. And we just want to make sure that these 2 are put together with everything else in the boosting stage, and then we will just change the staging. So these 2 are feeding into the main tank, and the main tank is also feeding into the SSTO's SSTO's rocket fuel tank. So that's something to keep in mind, guys. Okay, after fixing the staging, we can see that we have a total of 1011 meters per second with the boosters and 6.6 without them. So we have, guys, actually more than enough boosters to actually safely come to the interplanetary craft and dock with it. Okay, just adding some separatrons, because this will be a huge rocket, so we do want to make sure when the boosting stage or when our boosters are separated that they don't basically destroy the vessel. So, oh, wrong way. That's more like it. Okay, and we want to thrust limit them. We don't want them to go very fast. So this one was 17. Yeah, let's put this one to 17 as well. So boosters and separatrons, radial decoupler and separatrons firing at the same time. That's exactly what we wanted. Okay, let us now attach the launch clamps. I'm trying to figure out if there's any other place where I could be attaching the launch clamps. I can't. Okay, let us then simulate this vessel. We will be test simulating both the successful ascent and also the failed ascent. I want to see what happens. So currently we have only one Kerbal who is actually taking it up. And that's of course Jeb. Who else? Okay, throttle to max and decouple. You will notice here that I have put actually the thrusters and the launch clamps on 2 separate stages, and this is because our 5-meter engine takes some time to spool, so I wanted to make sure that we are thrusting with full thrust before decoupling those. Okay. I'm using RCS to actually keep this one in balance. We should have enough RCS. Note that our SSTOs don't have much SAS, but they should have at least enough so that we can decently go up. Our thrust weight is 1.22. It's not really stellar, but I'm kind of hoping it should be enough because we already picked up some speed. We are going supersonic, Mach 1. And I'm actually thinking that this guy has the best ascent profile yet. I do have to steer it. It does want to right itself up, and that's because yeah, the other side is slightly heavier, but RCS are making short work of these guys, so not much problem there. How are you doing, Jeb? Are you enjoying yourself? Okay, just checking the state of our actual fuel tanks. So far everything seems to be running smoothly, so I don't have overly reasons for major concerns. Our apoapsis is already past 80, so that's awesome, and our fuel economy is just peachy, so we have more than enough delta V to actually perform everything that we need to do. And a very, very nice ascent from this guy, if I dare say so myself. Perfect. So far the most efficient one. And let's shoot 130 by 130. Remember, the goal of this guy is just to get our 2 SSTOs to the interplanetary vessel. So the idea is, once we actually get there, we should still have some, at least some delta V, so that we can actually circularize, or not circularize, but rendezvous. Okay, pointing ourselves to the maneuver node. Seems everything seems to be working correctly. Like I said, guys, this is the first time for me that I'm actually doing something this crazy in terms of launching ships, but then again, I really wanted to do something special for our for you guys, since, I mean, we're celebrating 2,000 subscribers. Thank you very much for your subscriptions. They help me out a great deal, and I'm gonna try and keep making some good content. By the way, all the suggestions and critiques, as always, are more than welcome. Okay, so let's see. We have circularized 130 by 157 with 2,000 meters per second to spare. More than enough. Okay, perfect. So let us proceed with the tests, shall we? I just want to open and see. Okay, our monoprops are not fully recharged. So these are the V cylindrical monoprops. So we want to make sure that we empty those out. Okay. Okay, I believe we have correctly put them, filled the monoprop tanks, and I might consider bringing one larger monoprop tank on the main vessel, which then we will pump into the SSTOs just for that sake, because they have to have enough at least to dock, and I'm slightly concerned that they won't have enough, but let's see. Yeah, they are not fully fueled in terms of monoprop, so I'll have to obviously add that a little bit. Okay, let's get Jeb into one of them. Okay, and Jeb, you have of course chosen Discovery, not Voyager. Okay, board. And okay, perfect. This looks good enough anyway. So yeah, I mean, monoprop, we still do have a decent amount, but then again, we'll think about it. This is a nice screenshot which I had in mind, and yeah, Jeb, barrel roll in space, that always works. Okay, guys, so one more simulation to perform, after which I think we will call it this episode, and that's the launch failed episode, or test. So I think it will be quite a brief test, but we want to make sure that everything is working properly. So let's see. Okay, and 3, 2, 1, go. Launch clamps, and as the moment we pick up some speed, we will be hitting the abort. And here we go. Hoopa! Loop-de-loop. Our parachutes are obviously waiting negative deployment, which makes sense. And yes, seems that our hero will be landing a little bit lopsided, but what can you do? If he survives, I'll gonna call it a success anyway. By the way, guys, we are coming up to the end of this episode. Please like if you like the episode. Hit that subscribe button if you already haven't. So, thank you very much, guys, for watching. And this is GrunfWorks signing off.